Hi there, welcome back. Now we had discussed about rest and motion in the previous video. Now in this video we'll be catching up on that and we'll be discussing about position of the object and the frame of reference that is used to describe the position of an object. Now we said that the motion is relative in nature. Let's take an example for that. So here you can see a person A is resting on ground and this vehicle is moving in that ground, okay, and you have a tree also there. Now with respect to this man, that is man A, the tree is at rest. So if you ask the person A about the tree, he would say that the tree is at rest. But if you ask the same question to this person B who is traveling in the bus, so if you ask him what is the velocity, what is the state of motion of the tree, he would say the tree is moving backwards because the distance between the tree and the person will keep on decreasing. For example, this bus is moving with a velocity of 10 meters per second. See, about velocity and all we'll learn in the next videos. I'll just tell you, it is just, you understand that it is a speed, the speed with which the vehicle is moving towards right. Okay, so every second what will happen is 10 meters will be covered. Suppose this distance is 40 meters in the beginning. So next second the vehicle will have moved 10 more meters to the right side. So the distance between the tree and the person will have become 30 meters. So actually what this person is seeing is that the distance is reducing or the tree is coming towards him. So he would say that the tree is moving backwards. Similarly, if you ask the person B about this bag, he would say that the bag is not moving, it is stationary, because the distance between the bag and the person is not changing. At every instant it will be same. But if you ask person A about this bag, what would he say? He would say that the bag is moving towards right or moving away from him, because the distance, say this is 10 meters at this point. Later on, after a second it will become 20, after 2 seconds it will become 30. So what he would see is that the bag is moving away from him. So everything here is confusing because all the questions are about the same thing but the answers are different. It's all because of the perspectives or because of the change in observers. So with this example it is clear that motion is a relative term. Now let's discuss about position and the frame of reference that is used to describe the position. What is frame of reference? Frame of reference, it just means where the person, the observer, is placed, and it also includes 3 Cartesian coordinates, that is 3 perpendicular axes. Let's say x along this direction, y along this direction, and z is perpendicular to the board. I'll show it this way. I cannot show the perpendicular line properly, so I'll be showing here. So this is z axis. Now let's take this xy coordinate that is on this plane. Suppose the point is on this plane, say this is denoted by P. Okay, so how do you describe the position? For describing the position you need one thing, the distance from the observer. Here the observer is here, observer is at the origin, so you need the distance and also you need the direction given by angle. So this description of position is called radial coordinates, the distance from the origin and the inclination from the origin along any direction. So that is one way of showing. Another way is using the Cartesian coordinates. What is the meaning of Cartesian coordinates? If you drop a perpendicular to x-axis, the distance from the origin to this point is called the x component or x coordinate. Similarly, if you draw up a perpendicular to the y-axis, you'll get y coordinate over here. This is y coordinate, right? Now, we can describe a certain thing called position vector. What is a position vector? Position vector is the vector denoting the position of the particle. This point is at this point, at this place, and so position can be described by showing an arrow from the origin. This is the position vector. So position vector will be the component in x direction into I cap. What is the meaning of I cap? It is a unit vector along x direction, plus this is the magnitude and this is the direction, plus y into j cap. What is j cap? Y is the magnitude of the distance along the y direction, and j cap is the unit vector along y direction. So this is how you describe the position of a particle or an object. If you take it in 3 axis, what will happen? I'll erase this and show. If you take it in 3 axis, suppose this is x axis, this is y, this is z, and the particle is somewhere in the space. If you join that, now if you drop a perpendicular to y axis, this is 90. If you drop a perpendicular to x axis, and if you drop a perpendicular to z axis, so this coordinate will be z, this will be x, and this will be y. So if you're writing the position vector for this, it will be x I cap plus y j cap plus z k cap. I hope this is clear. So we'll be continuing from here in the coming video. Don't forget to like the video, share it, and subscribe to my channel. Thank you.